we're ready to begin chapter 3 today, solving linear equations. It's kind of the final review of all things before algebra, although it is algebra. So today we'll start with one-step equations. It should take us back to 5th and 6th grade, actually. So I'm sure you'll feel strong here. Here is an example equation, 3y equals 18. So what is the operation that is taking place with 3 and y, Bianca? What operation is happening here? When you see no operation, it just says 3y.
Multiplication.
Very good, multiplication. So what is the inverse of multiplication, everyone? Division. So in order to get y isolated, what will we divide by? 3. Good, 3. So we divide both sides by 3. And we end up with 3 over 3. 3 over 3 equals? 3 over 3 equals 1, right? 1. So we have just 1y, which we don't even have to show that coefficient 1. It may remain invisible, right? And 18 divided by 3 is? 6. Good. So inverse operations kind of undo each other, don't they? 3. Instead of leaving the 3 as a factor being multiplied to y, we want to undo that to get y alone. So we use division in that case, right? So inverse operations are two operations that undo each other. Multiplying by 3 and dividing by 3. They undo each other. So we actually have two equations now in front of us. We have the red equation, 3y equals 18. And we have this blue equation, y equals 6. And these are equivalent equations. We really just transformed the first, didn't we? Using our inverse operations. And so what is the solution? Here's that word solution. We talked about that last week. When you have an unknown, then you could find a solution. In many cases you can, and today you really will be able to because we have just one unknown in this equation. So what is the solution for y in the red equation? Y equals 6. And in this equation down here is so simple, but if y equals 6 is the equation, then what is the solution for y? Isn't that strange? It's so, it doesn't look like you should fill it in because it gives you more information to know that y equals 6, right? But equivalent equations are equations with the same solution. These two equations have the same solution, 6. You could have more elaborate, more complex equations than these, and they might have the same solution. If they do, they are equivalent. Are we good? Okay. So let's go over some properties of equality. How do we maintain equality? And so this is addressing our inverse operations. So the addition property of equality says if we're going to use addition in an equation in order to isolate a variable, then what operation will be in the original equation? If we have to use addition to get a variable isolated, then what operation was in the original equation? It was subtraction. So here we see x minus a equals b. If our goal is to isolate x, then we need to get rid of this minus a. And so what is the inverse of minus a? Casey? Plus a. Good. So here we see if x minus a equals b, then x minus a plus a would equal b. Say it. Plus a. What you do to one side of the equation, you must do to the other side in order to maintain equality, right? And now when we look at this, x minus a plus a, we actually have opposites, right? Or inverses here. what do we have left if we have x minus a plus a? On the left side, Bailey, what do we have left? X, she's saying x, right? Equals what? What's on the right? Is there a way to change or simplify b plus a? No, I mean, we don't know what they are, right? So we're going to have to leave it b plus a. Right. Okay. So when we look at the original expression, x minus a equals b, an equivalent expression would be going way over to the end here. X equals b plus a, right? Okay? And that's because we added a to both sides. All right? So if we're going to show the subtraction property of equality, what operation will we see in the original equation? If we're using subtraction to isolate a variable, what are we going to see in the original? Addition. Okay? So if x plus a equals b, now I've covered the entire next step. How can we use a subtraction property to isolate x? Everybody try it, jot it down. We're using subtraction to isolate x. Okay, so Sophia, what subtraction will we use to isolate x? Good job, minus a. So it'll say x plus a minus a, but what you do to the left expression, you must do to the right. So equals b minus a. Very good. And so as we look at the left side of this equation, we have plus a and minus a. And those are inverses, right? They undo each other. And what are we left with on the left side? On the left side, everyone, what are we left with? X equals on the right? B minus a this time, right? So x plus a equals b is equivalent to x equals b minus a. So of course we have a multiplication property of equality. If we're going to use multiplication to undo another operation, what is that operation we're undoing? Division. So we're going to see division and then use multiplication. Who can tell me what we're going to see? What do you think, Jimena? Okay, if we see x times a equals b, then in order to get x alone, would we be using multiplication? Okay, so that's going to be the next rule we get to, right? But this one is actually using multiplication. That's why it is the multiplication property, see? So instead of what you said, x times a, what would you say? Good, x divided by. So we will end up using multiplication here to isolate x. Riley, what will we multiply by? A. And we'll multiply both sides, right? So can you tell me what it looks like? X over, okay, x, well, actually you have simplified it. You gave us this equivalent expression, but you multiplied both sides. So the next step would say x over a times a, good, b times a. And then she took it and simplified. Multiplying and dividing by a undo each other, right? It becomes 1x. So as she said, x equals b times a, or ab. Okay? So now, Jimena, you said the division property first, didn't you? So you want to tell us again? If x times a equals b, or in this case it says a times x equals b, then we're trying to get x alone, so we would have ax. We're trying to get x alone, so leave the x there and divide by the other factor, right? Good. Okay. So we end up with ax divided by a equals b divided by a, okay? And now we see these inverse operations. And let's say the final step together. Ready?
X
Equals
B
b over a. Good. X equals b over a. What's that? Wow. That must have been something left over from some discussion I had there. X equals b over a. Okay. These should feel so incredibly easy, right? Do take the equation down, and then maybe use a red pen and show how you're solving it using an inverse operation. Okay? Yeah, and you can pause the video and come back and check your answers here. Okay, number one, the operation that we're using to isolate y. Can you name it? Faith. Subtract what? Just go ahead and say what we need to do. And it's subtracting 7 for both sides. Right? So y equals 3. Good. Number two, Jonathan, what operation? Subtracting what? Isolating x, what will you do? Okay, so we actually add 5 to both sides in number 2. We have x equals 8. Number 3, Sabrina. Yeah, divide both sides by 4, and you end up with? Good job. And then, of course, you can check these, right? By just plug it in, right? 4 times 12 is 48. You can take every solution and substitute 3 plus 7 is 10. And then 8 minus 5 is 3. So always at least take a little mental check of it, right? Of your answer. And then finally, the last one, what will we do here? The operation is? Multiply by? Negative 8. And so we end up with 1n, right, equals negative 24. Good. Okay. What happens if we're multiplying by a fraction? Really, when we look at this, 5, 6w is saying 5 times w divided by 6. We're timesing and dividing all in one fraction. 5 times w divided by 6 equals 10. Or we say we're multiplying by 5, 6. So who remembers the one inverse operation a person could use to isolate the w here? Zach. Very good. Multiply by the reciprocal. Okay, don't forget to use that time-saving strategy, right? So we multiply both sides by 6 over 5, which I have to say some of you forgot in the test. When you were dividing by a fraction, there were actually people who multiplied by the same fraction. And instead we were to multiply by the reciprocal. So it's too bad. Oh well, things happen. Okay, so do you see a way we can simplify this a teeny bit, Nico?
10 goes into 5 twice.
That's 2. So 2 times 6 is
12.
12. Okay, and if you wanted to check this, the original equation said 5, 6 times w, which is now 12, times 12, does that equal 10? Does that equal 10?
Yes.
So 6 goes into this 12 twice as well, right? 5 times 2 is 10, so you can check it. Okay? You'll have a couple of word problems today, so you need to pause the video to try it because we're running short on time. Okay, so we start with our formula, d equals rt, and when we substitute the known information, we have one variable. We simply had 200 meters equals rate times 19.79. And now we undid that using the inverse operation division. And we see that he travels actually at about 10.1 meter per second. Now think of this meter stick. I'm going to do this for the computer.